Okay, so we're going to be practicing chain rule, but when we have to do chain rule during the second derivative, taking the second derivative, okay? So basically chain rule when we got to go past the first derivative, okay? So let's look at number one. We have f of x equals 6 times x cubed plus 4 cubed, okay? So I definitely have a function inside of a function. So I got to take the first derivative. So f prime of x equals 6 times, now I got to do the chain rule here. I'm going to use inside-outside rule. So the derivative of the inside is 3x squared times the derivative of the outside, which is that cubic out there. We move the 3 out front, we get x cubed plus 4 squared because we subtract 1 from the power. Now let's simplify the first derivative so that when we go to take the second derivative, it makes it easier. So we get 54x squared times x cubed plus 4 squared. Now we're going to be taking the derivative of this. Okay, so this is the first derivative. So now we got to take the second derivative, f double prime x. Well, as soon as we did the chain rule for the first one, now we have actually product rule going on because I have 54x squared times x cubed plus 4 squared. So yes, I have chain rule inside here, but the main idea, the main derivative idea we're using is product rule, and then we have a chain rule inside of it. So when I take 54x squared, the derivative of that is 108x to the first power. So it's the derivative of the first times the second plus the first times the derivative of the second. Now we're taking the derivative of this second part, which that's where our chain rule. So I'm going to do inside-outside rule again. So the derivative of the inside is still 3x squared times the derivative of the outside. You move the 2 out front. X cubed plus 4, subtract 1 to the power, you get 1. And let's clean this up a bit. So we get 108x times x cubed plus 4 squared plus, and then when you multiply this out, you're going to get 324x to the fourth times x cubed plus 4. And that's your second derivative. Okay? So sometimes we have chain rule going through all of it, or sometimes when we do chain rule the first time, we end up in a situation where we're going to have to do product rule to find the second one. Okay? So let's look at number 2. So g of x equals 1 over 2x plus 5. Now again, if I'm looking at this, I could do quotient rule if I wanted to, okay? But it would be much easier to change my g of x to this, 2x plus 5 to the negative 1 power, okay? Much easier to do this way because we don't have negatives, you know, in the quotient rule we have that negative on top and we don't have a bunch of stuff flying around like that, okay? So g prime of x, derivative of the inside, which is 2, times the derivative of the outside. We move the negative 1 out front, and we get 2x plus 5 to the negative 2 power. Okay, so let's clean it up. So negative 2 times 2x plus 5 to the negative 2 power. So that's our first derivative. So now we're going to take the second derivative. So g double prime of x. So we have that negative 2 from the first one times the derivative of this, which inside-outside rule again. So the derivative of the inside still 2. Then we move the power out front, negative 2 times 2x plus 5 to the negative 3 power because we subtract 1. Clean it up. Negative 2 times negative 2 is 8, and 2x plus 5 to the negative 3 power, or 8 over 2x plus 5 cubed. And that's the second derivative. Okay. So in the first one we had chain rule and then we had product rule. This one we just had chain rule and then chain rule. Okay? So let's look at number 3. So this is sine of t squared. This is not sine squared t or sine of t squared. This is actually inside the sine function. So we do have chain rule going on here. So I'm going to go straight to doing the inside outside rule. So the derivative of t squared is 2t times the derivative of the outside, the derivative of sine is cosine t squared. Okay, so there's my first derivative. Real easy, straightforward. Okay, now we're finding the second derivative. Now that I'm taking the second derivative, and you can see right here I have this multiplication, so here again I have product rule. I did chain rule and now I have a product rule that I have to do. So derivative of the first, derivative of 2t is 2 times the second, cosine t squared, plus the first times the derivative of the second. So here I got to do chain rule because again this is inside. So the derivative of t squared is 2t times the derivative of cosine, which is negative sine t squared. And again we want to clean this up. So we get 2 cosine t squared minus 4t squared sine t squared. And that is our second derivative. All right. Number 4. So there's nothing to simplify here, so we're going to go straight to the derivative. And when we're taking the derivative of this, we're going to end up with product rule that we have to do. So derivative of the first, 3x squared, times the second, plus the first times the derivative of the second. Okay, so there's our first derivative. So now we're going to take the second derivative. So when I go to take y double prime, and I go to take the derivative of this first part right here, I've got product rule. So I got to do product rule again. So the derivative of first is 6x times e to the x plus 3x squared times e to the x. So this is the derivative of that. Okay? Plus, that's that plus sign. Now we have to do the derivative of the second part. So this right here, we're going to do that derivative. And again, we have chain rule. But if you notice, look, this right here is what we started with right here, x cubed e to the x. So basically, this is y prime. This is our first derivative again. But if we did it again, the derivative of the first is 3x squared times e to the x plus x cubed times e to the x. So this is the derivative of that one. Okay? And again, we want to clean this up a little bit so that our second derivative looks presentable. And notice that all of our numbers have e to the x. So I'm going to take out an e to the x, and I'm left with 6x from here, plus 3x squared from here, plus another 3x squared from here, plus an x cubed here. And when we simplify it down, we get e to the x, and this is x cubed plus 6x squared plus 6x. And that is our second derivative.
You've got mail.
Now, we could have made it a little bit easier on ourselves at the first derivative right here if we had done that simplification first. If I had changed it to y prime equals e to the x times x cubed plus 3x squared and simplified it even more in the first one, when I go to take the second derivative, I'm going to take the derivative of e to the x, which is e to the x, and then I get this, plus e to the x times the derivative of this one, which is 3x squared plus 6x. And then you see how these two have e to the x, and I could have taken that e to the x out, which would have left me with x cubed plus plus 3x squared plus 3x squared plus 6x, like that. And of course, when you add like terms, you still get there. Okay? Either way, it depends on how you want to do it. Okay? You could simplify first, or you could simplify at the end. And now our last problem. Our last problem deals with velocity. Okay? So given the following position function, identify the times at which the particle changes direction. Okay, so we're talking about when the particle is changing from direction, from either forward to backwards or up to down. Okay, so this is our position. Well, a particle changes direction when the velocity changes direction from positive to negative, because positive velocity you're going forward, negative velocity you're going backwards. Okay, so the first thing I need to do is I need to find velocity. And you should know by now that the derivative of position is my velocity equation. So you take the derivative, which gives you 3t squared minus 10t plus 4. So since we're looking at where the particle changes from positive to negative or from negative to positive, the only way you get from positive to negative or negative to positive is if you pass through 0. So before I can find out where it's negative or positive, I need to find out where the velocity is equal to 0. So this one right here is not factorable with just common factoring. You'd have to either do quadratic equation or you could graph it. But when you find your values, you get t equals 5 plus or minus the square root of 13 over 3, which means t is approximately 0.4648. T1 and T2 is approximately 2.868. Okay? So now what we're going to do is since we know where our velocity is 0, so this is T1 and this is time 2, those are my zeros. That's where it's 0. This should look familiar. I'm doing a derivative test. I'm testing to see if the velocity is positive or negative in these other areas. So on this side, I'm going to plug in 0. And when you plug in 0, you get positive 4. So it's positive there. Then I'm going to plug in 1 into my velocity equation. And when you plug in 1, you're going to get negative 3. So this is negative. Then I need to plug in a value bigger than 2.8. So I'm going to plug in 4. And when you plug in 4, you're going to get a positive number. So right here, I'm testing the velocity. And when I test the velocity, that allows me to find out where the velocity is positive or where it's negative. And where velocity is positive, it's going forward. Where it's negative, it's going backwards. And you can't get from the positive to the negative sign without going through 0. That's the intermediate value theorem. Okay? Intermediate value theorem says if you're going from one point to another point, you have to cross all the points in between. So to get from positive values to negative values, you got to cross through 0, which means these are the times where my particle changes direction from forwards to backwards or from backwards to forwards. So it looked like it was a complicated physics problem, but in reality, we did nothing more than do a first derivative test. And this is what makes some of these problems complicated, because it looks like we're doing something totally different because of the way they ask the question. So just be careful. The best way to remember these types of problems is to kind of write out flashcards for the types of problems they ask, and on the back, how to do them. Okay, and we'll talk more about that in another video.